the time x hours for which students use a games machine in any given day has a normal distribution with mean 3.24 and standard deviation 0.96. You have come across information, make a note. Mean is 3.24 and standard deviation is 0.96. Find the probability that the number of hours for which a randomly chosen student uses a games machine in a day is within 1.5 standard deviations of the mean. Read this one more time. Within 1.5 standard deviations of the mean. You need to find the probability within 1.5 standard deviations of the mean. And how do you understand it means? See, if I take normal distribution curve and here is the mean, he said within 1.5 standard deviation of the mean. See man, 1.5 standard deviation means 1.5 times of standard deviation of the mean. Of the mean means it could be either towards the left or towards the right. If I go towards the right, this will be the place of 1.5 times of standard deviation. Towards the left means this will be the place where minus 1.5 standard deviation. Clear? Now, it's not mentioned whether to the left or right. That means we have to find this entire area. The area itself is nothing but the probability. Clear? Within means it could be either left side or the right side. So take both, find the area. Area itself is the probability. Clear? Now, how do I find this? This is similar to the between questions. Okay. Now, how do we find it means? See. First, I take entire left side of mu plus 1.5 standard deviation, this entire area. From that, I remove the left side of mu minus 1.5 standard deviation. Clear? Now, understand this. Let us say here it is mu minus 1.5 standard deviation. From the total, I am removing this. So, I will be left out with this one. Clear? Now, how do we represent it means in this way? P of mu minus 1.5 standard deviation less than x less than mu plus 1.5 standard deviation equal to, this is entire left side of mu plus 1.5 standard deviation. So, x less than mu plus 1.5 standard deviation minus this also left side of mu minus 1.5 standard deviation. So, P of x less than mu minus 1.5 standard deviation. Clear? This is how we find the in between area man, or that itself is probability. Now, in every normal distribution question we have to make use of this one, and that is P of x less than n is nothing but phi of n minus mean by standard deviation. Here you should check out for this symbol. Here it has to be less than. Whenever it is less than, only then P will get converted to phi. Clear? Now see here. Here the symbol is less than. So P will get converted to phi of mu plus 1.5 standard deviation minus mean by standard deviation. Okay. Now, here also the symbol is less than. So P will get converted to phi. So phi of mu minus 1.5 standard deviation minus mean by standard deviation. Clear so far? Next, how do we simplify? See man, does anything cancel out? Yes. plus mean and minus mean will get cancelled. You are left with 1.5 standard deviation by standard deviation. Now over here, does anything gets cancelled out? Yes. Plus mean minus mean, you are left with minus 1.5 standard deviation by standard deviation. Okay. Next, furthermore, does anything cancel out? Yes. And that is standard deviation and standard deviation. So you are left with phi of 1.5 minus same here. Cancel out, you are left with phi of minus 1.5. Now, we have to make this into positive. For that, we have to do 1 minus. What I mean is phi of 1.5 minus 1 minus phi of 1.5. Whenever I did 1 minus phi, the negative will get converted to positive. Phi of negative, if you do 1 minus, it will become positive. Now, open up the bracket in this way. So, I get phi of 1.5 minus 1 minus minus plus phi of 1.5. Now, phi of 1.5 and phi of 1.5 both are same. It will result in 2 times of phi of 1.5 minus 1. Now, you get this value from the normal distribution table and you should get it to be 0.9332 minus 1. Now, if any doubts in making use of normal distribution table, look at the playlist given in the description. Now, put this in the calculator. You get the answer to be 0.8664. Okay. So, whenever within question comes, this is how we should do. Okay.